The data from 2024 has effectively upended decades of climate modeling, with ocean heat anomalies and ice melt rates reaching levels that many researchers describe as staggering. When the Copernicus Climate Change Service confirmed that 2024 was the first full calendar year to exceed the 1.5 degrees Celsius warming threshold, it wasn't just a round number, it was a signal that the planetary system might have shifted into a new, far more volatile acceleration phase. The sheer velocity of these changes, especially in the deep oceans and at the poles, suggests we're no longer just dealing with a gradual climb, but a potentially systemic rupture in how the Earth regulates its temperature.
It's a shift that has sparked a massive debate among climatologists. On one side, you have figures like James Hansen, often called the godfather of climate science, who argues that warming is accelerating significantly, potentially by 50 to 100% over the coming decades, compared to the post-1970 average. Then you have researchers like Zeke Hausfather and Michael Mann, who, while equally concerned, argue that most of what we saw in 2024 is still broadly consistent with our existing models if you factor in the massive El Niño event and the reduction in sulfate aerosols from shipping fuels. But even if the physics makes sense, the scale of the anomalies is what's freaking everyone out. In the North Atlantic, for instance, we saw sea surface temperature deviations that were statistically categorized as 1 in 284,000-year events. When you hit a number like that, the word unprecedented starts to feel like an understatement.
That North Atlantic data point is haunting because the ocean is supposed to be our buffer. It absorbs about 90% of the excess heat we've trapped in the atmosphere. If the buffer itself is starting to overheat this violently, what does that mean for the global circulation? Specifically, I'm thinking about the Atlantic Meridional Overturning Circulation, or AMOC. There was a major study out of the University of Miami recently that used direct seafloor measurements rather than just proxies, and the findings were grim.
That study in Science Advances is a game changer because it bypasses the proxy debate. By using bottom pressure measurements at 4 key sites along the western boundary, they found that the AMOC has been weakening for nearly 20 years, and the projected slowdown is much faster than the IPCC's previous estimates. Instead of a 30% decline by 2100, we might be looking at a 51% drop. This is the conveyor belt that keeps Europe temperate. If it continues to stall, we get the cold blob in the North Atlantic, a pocket of cooling in a warming world that actually messes with the jet stream and fuels more extreme weather patterns across North America and Europe. It's a paradox. The faster the ocean warms globally, the higher the risk of a localized collapse in the systems that move that heat around.
And the sheer energy involved is almost impossible to visualize. When the 2024 data showed that ocean heat content increased by 16 zettajoules in just 1 year, it's a number that doesn't mean much to a layperson until you translate it. Some researchers have compared it to adding the energy of hundreds of millions of Hiroshima-style bombs to the water in a single year. That's about 140 times the entire world's annual electricity generation dumped into the sea.
Exactly. And that energy isn't just staying at the surface, it's penetrating deeper. The upper 2,000 meters of the ocean reached record-high heat content in 2024 across almost every basin, the Indian, the North Pacific, and especially the Southern Ocean. This is why the ice data from Antarctica is so alarming. For decades, Antarctic sea ice was the odd exception. It was actually growing slightly while the Arctic melted. But that trend snapped in 2016, and by 2023 and 2024, we entered what scientists are calling a regime shift. The winter maximum in September 2024 was the second lowest on record, only slightly above the disastrous 2023 low. We are essentially losing an area of sea ice the size of Texas every year compared to the historical average.
Why is the shift in Antarctica so much more significant than what we've seen in the Arctic? Is it just the scale, or is there a specific mechanism there that acts as a tipping point for the rest of the world?
It's both. Arctic ice loss is tragic, but it's largely expected based on the geometry of the North Pole. Antarctica is different because its sea ice acts as a buttress for the massive land-based ice sheets. When the sea ice vanishes, the warm circumpolar deep water, which a Cambridge study recently showed is moving closer to the continent, can flow directly underneath the ice shelves. This melts them from below. These shelves are like the corks in a bottle. They hold back glaciers that have enough water to raise sea levels by 58 meters. In 2024, NASA oceanographer Josh Willis pointed out something incredible. 2/3 of the sea level rise we saw wasn't from melting ice, but from thermal expansion. The water is getting so hot, it's literally taking up more physical space. Sea level rise soared to 0.59 centimeters in 2024, way above the predicted 0.43 centimeters.
It feels like we're watching a feedback loop settle in. The more ice we lose, the less sunlight is reflected back into space, the albedo effect. But 2024 also highlighted the role of water vapor. Since warmer air holds more moisture and water vapor is itself a potent greenhouse gas, the record atmospheric water vapor levels in 2024, nearly 5% above the 1992-2020 average, are essentially insulating the planet even further.
That's the trap we've built. The ocean's surface evaporation is accelerating, fueling that water vapor surge, which then traps more heat, which then goes back into the ocean. We also have to talk about the aerosol termination effect that James Hansen is so focused on. For decades, we were inadvertently cooling the planet with sulfur pollution from ships. Since new regulations kicked in during 2020 to clean up shipping fuels, that umbrella of reflective particles has thinned. Hansen argues this has unmasked the true strength of the greenhouse effect, leading to this sudden jump in temperatures. While some experts think he's overestimating the impact, the 2024 data, showing a 2.9 ppm jump in CO2 levels, one of the largest in history, doesn't give much comfort. We're hitting the system from both ends, increasing the insulation while removing the temporary sunshade.
The human impact of these ocean anomalies was also visible in 2024 through the record-breaking marine heat waves. The Mediterranean, for example, hit 28.5 degrees Celsius in August, the highest ever recorded. We're seeing parrotfish and other tropical species moving as far north as the Saronic Gulf. It's a complete restructuring of marine ecosystems happening in real time.
And it's not just the Mediterranean. There were record-high marine heat wave days globally in 2024. These aren't just warm patches, they're ecological dead zones in some cases. They cause massive coral bleaching. 2024 saw the most extensive global bleaching event on record, and they decimate fisheries. But even more critically for those of us on land, these heat waves are the engines for extreme weather. A hotter ocean transfers more heat and moisture into the atmosphere, which is why we saw such catastrophic flooding and unprecedented storm intensities in 2024. When the sea surface is off the charts, the storms that pull from that energy are going to be off the charts too.
There's also the question of the land-based glaciers. The 35th annual State of the Climate report from the American Meteorological Society was pretty definitive. For the second year in a row, every single one of the 58 global reference glaciers lost mass. Venezuela officially became the first country in modern history to lose all of its glaciers. It's a symbolic milestone, but also a practical disaster for regional water security.
The mass loss is accelerating. About 41% of all glacier melt since 1976 has happened just in the last decade. In 2023 and 2024, the loss exceeded 430 gigatons of water per year. To put that in perspective, that's more than a millimeter of global sea level rise every single year just from those mountain glaciers, independent of the big ice sheets in Greenland and Antarctica. It's the sheer synchronicity of it that's so alarming. Usually, you'd have some regions gaining ice while others lose it due to local weather variability. But in 2024, there was no cold spot. 95% of the Earth's surface was significantly warmer than the mid-20th century average. Only 0.2% of the planet was significantly colder. We've effectively eliminated the planetary cool zones that used to balance the budget.
So where does the debate go from here? If we have scientists like James Hansen saying the acceleration is undeniable and standard physics, while others say we need another 5 to 10 years of data to be statistically certain, are we just arguing about the label while the house burns down?
In a way, yes. The statistical debate is about whether the rate of warming has changed. If the rate was 0.18 degrees per decade and it's now 0.3 degrees, it takes a while for that signal to emerge from the noise of natural variability like El Niño. But the physical reality, the zettajoules of heat, the trillions of tons of ice lost, the record water vapor, that's all measured and confirmed. Whether you call it an acceleration phase or just the expected result of high emissions, the outcome is the same. The system is becoming more energetic and less predictable. The memory of the ocean is changing. In Antarctica, the sea ice doesn't recover like it used to because the subsurface water stays warm all winter. That's a structural change, a regime shift. You don't need a 10-year average to see that the rules of the game have changed.
It's the loss of predictability that's the most dangerous part. If our models from even 5 years ago are failing to capture the intensity of the 2024 anomalies, our ability to prepare for sea level rise or extreme crop failures is compromised. We're essentially flying a plane where the instruments are starting to give erratic readings because we've entered a storm we didn't think was possible yet.
That's exactly how researchers like Sarah Perkins Kirkpatrick and Carlo Buontempo are describing it. They use words like unnerving and gobsmackingly bananas because the data is literally falling off the top of the charts they've used for their entire careers. The 1.6 degrees Celsius mark for 2024 isn't just a number to be filed away. It's a demonstration that the Earth's energy imbalance has reached a point where the planet is shedding its old stability. If the AMOC continues to weaken at the pace the Miami study suggests, and if the Antarctic sea ice memory stays lost, the 2030s are going to look very different from anything we've prepared for. The volatile acceleration phase isn't a future threat. The 2024 data suggests we are already living in it.
The reality of 2024's climate data serves as a stark reminder that the window for gradual transition has likely closed, and we are now navigating a world of rapid, systemic shifts. Understanding these anomalies in ocean heat and ice melt is crucial for anyone trying to grasp the scale of the challenge ahead. If you found this analysis helpful, share this episode with someone who needs to see the data behind the headlines.